So take a look at this here, and let's recall, is that a good system to use elimination method on?
No.
I mean, sorry, substitution method on? And why? What gives it away that it's not? What was the? If I told you I want you to use substitution method on this, what would you say is probably not favorable?
None of those numbers go into each other.
Yeah, 6 doesn't go into 5, 5 doesn't go into 6, 6 doesn't go into 7. So the first thing is, now that we're going to have multiple tools for doing the same thing, you have to know when to use that tool. You can't just count on me to tell you to use substitution, and you can't blindly just use elimination all the time once you learn how to do it, because maybe you like it better. You got to know when to use which one. Okay? So it's kind of like you have a hammer and a screwdriver in your bag. You have to be able to look at what you're trying to do and say, well, which tool is better for this job? Trying to hang something? Probably a hammer. Okay. Trying to tighten something? Probably a screwdriver. You got to know which one's better. So the first step is knowing that this is not good for elimination. So what's next? Okay. Show you a background here that if I take two equations, and these are probably the basic, most basic equations there are, 4 equals 4, 2 equals 2, and I go ahead and add them up like an old elementary school addition problem. Just draw a line, put a plus sign, and I add the left together, and I add the right together, and I write it down here, I still get a true statement. The fact that it's true means I can do it no matter what. So I can do, if I can do it with just numbers and it's true, I can do it with variables, and it's still the same thing. So in math, we have properties. The properties work for numbers and variables. So it's true for numbers, we can do with variables. So what happens if I try to do something like this, but with equations? All right, so 2x plus 3x, 5x. And negative 5y minus 5y is 0. Hence, elimination. One of the variables is eliminated. On the other side, write down the equals. 10 minus 5 is 5. Now, can you solve this? Yeah, x equals 1. Now, could you plug this back in and get what y equals? Yeah, that's the same thing you did on elimination. So the only thing new here is right here. This is why it's called elimination, is because we're going to add equations together, and one of the variables will be eliminated usually. Now there is a possibility both of them will be eliminated. That's when you get a no solution or an all reals, because you'll get like 0 equals 0 or 1 equals 2. But most of the time, one of the variables will be eliminated. And besides that, everything after this is the same exact thing. So it's kind of a good news, bad news. We'll have to do more of this plugging back in, getting the answer, and then checking it. Like, yeah, but the good news is, well, you pretty much know how to do 80% of the problem. The question is that, can you set these up so that one of the variables gets eliminated when you add them together? Okay. So the first thing is just looking up two equations and seeing, well, does something get eliminated if I add these together? So let's look at that. So on these three here, does anything get eliminated on this first system of equations? What gets eliminated? The y's. Yeah, you get 1 minus 1. So what does this equal?
2x.
And over here? Negative 2. And be careful on those negatives, because those will drive you crazy. You do all this work and you find out you missed one negative. So be very careful. What about the second one? Yeah, this time the x's. So similar to elimination, we can work with the x's or the y's. It doesn't matter. We're getting comfortable with that probably by now. We're so used to doing y equals for everything that now it doesn't matter. What do we get here? Negative 5. So negative 4 and negative 1 is negative 5 equals. Okay. And then down here, yeah, y is equal, cancel again. And of course, I'm just doing up to this point, but you have to know, okay, solve this, divide both sides by 2, x is -1, plug it back in, you still have to find out what y is. So your answer is still the same thing. We're still solving the same problem as we were on Monday. We're just solving a different way, but the answer is still the same. If we solve both of these for y, if I got y equals -x -4, if I graph that, I'd have to see where it intersects with y equals x plus 2, right? So same problem as if we were graphing these and seeing, okay, where do these two intersect? Okay. So here we'd have, we divide both sides by -5, +1, still have to figure out what x is, divide both sides by 5, so we get x equals 2, still have to find out what y is. I'm just covering this first part because that's the only thing that's new. And you'll keep on going. Okay. Now, just so far, do you feel like this is easier, harder than substitution? Easier. Okay. Now, the reason for that is that I've given you nice equations that everything cancels out right away. So just like substitution, we did kind of like an easier day on Tuesday. Yesterday was a little bit more work. So you're probably still thinking about yesterday's harder substitution problems and comparing it to these easier elimination. Tomorrow we'll get a little bit more involved, and then you'll probably be thinking, well, substitution is actually easier if I have a y equals. I don't have to do any prep work. It's already ready to substitute, and I'm done. And then, but if you come across two equations and you have one positive and one negative of the same variable, you'll say, oh, elimination's easier. So I know you're probably leaning towards elimination now. I'm going to use this all the time, but it will get a little bit more involved tomorrow. And for now, we'll just practice on something a little easier. Okay, let's just go through a few of these, just doing the first step. What do you get on the left-hand side here? 5x, good. 3x plus 2x. What do we get here? 0. Yeah, that's why it's called elimination. We eliminated a variable, which means it equals 0. What do you get on the right-hand side? Negative 15? 15. Positive 15, yeah. So we're being very careful. The thing after you learn how to do all this, the mistakes will be stuff like that. So be careful. And then, of course, go ahead and finish it. Right? And you guys are experts at this by now. Plug it back in to one of them, get what y is, you use the other one for a check. So you should never finish anything wondering if it's the right answer. Okay? And from this point on, again, it's all review. That's what we've been doing all week. So I just want to go through a few of these and then get you guys started on your homework. So you can get any question there if you might have. Let's see here. Already talked about this, and you'll definitely have no solutions and infinitely many solutions tonight also. What about here? What do we got?
Besides cancel.
Yeah, 0, 0. So the left-hand side is 0. And right-hand side is
0.
Therefore, the answer is
Infinitely many solutions.
Yeah, infinitely many. So infinite solutions. All right. Which means, what does that mean if I try to graph these? What will it look like if I graph these two? Yeah, these are the two. These are exactly the same line. Look at them closely. Aren't they almost the exact same thing anyway?
Yeah.
Yeah, this one's -4, +4. This one's -2, that one's +2. This one's 4, this one's -4. So if I just took this one and multiplied everything by -1, it would be the top one. It's the same exact equation. If I went through and did the slope-intercept form, they both come out to the same exact slope and y-intercept. So when you see this infinite solution, we want to know graphically, if we solve for slope-intercept form, it's the same exact thing. 100% the same. The no solution, you'd have the same slope, but the y-intercepts would be different, meaning they'd be like parallel lines. That's when you get like 1 equals 2. So slightly different if you solve and graph those. Okay, so we now know these. No problem. If I have a variable that has a positive and a minus, and if I add them together, they eliminate, that's perfect. I can finish the rest of this. What do I get? 3? Now, what if I have this? Does anything eliminate here? No, I get 8x, and I get 3y. This is a red flag. Nothing is eliminated. If you add them together, but nothing eliminates, then you have not used the elimination method properly because nothing has been eliminated, right? However, what would you change about one of these for the elimination to work? So, well, fancy way of saying it is that, well, if one of these was a -4, everything would be fine. Okay, now it eliminates. Now, but am I allowed to just change this to a -4 because I want it to be -4? Kind of, but I can't just change the first one. I'd have to change all of them. Someone mentioned it's kind of like multiplying everything by a -1. That will change this to a -4, but then it'll also change this to a -2. It'll change this to a +10. Right? It just changes the sign, leaves the number alone, changes the sign. And now I have 4 minus 4 eliminated. 1 minus 2, -1. And now I have -9 plus 10, instead of minus, plus 10. So that's going to be 1. And now you can go ahead and see one of them has been eliminated. I used the method correctly, and carry on like normal. So these will be your 2 types. Some of them will have it already set up for elimination, and then you'll see some that are, well, almost there, except, well, I wish that one was negative. Or they might both be negative, and you'll say, well, I wish that one was positive. It's the same thing. You just change all the signs of all 3 terms. Okay. Tomorrow, well, if this is, it looks like we've covered everything. What are we going to talk about tomorrow if we're going to do a whole other day on this? So tomorrow is, well, what if I have this? Right? Substitution doesn't work because 2 doesn't go into 3, 3 doesn't go into 2, 4 doesn't go into 5, 5 doesn't go into 4. And I can't just change the sign. No matter if I just change the sign anywhere here, nothing gets eliminated. So there's one more step we have to talk about is, well, what if we don't have a 4 and 4 or a -3 and +3? We'll do one more step tomorrow, but more or less it'll be one quick step, and then everything else after that's the same. So we really laid the foundation for all of these problems. Okay? We're just talking about tweaking the very beginning just a little bit to get what we want. Get down to one variable where we can solve very easily, plug back in, get the other variable, have our answer, right, and do a check. It's the same process for all of them. Okay. Some things have changed. Sometimes you find the first variable first, -1. Sometimes you find the y first, -1. So there are some minor differences, but more or less we're doing a lot of the same stuff. Okay, so let's take a look at your homework. Let's get that out. And as usual, look at everything, preview it, and see if there's anything on here that we should probably go over, talk about, or clarify before leaving this room. Now, number 1, we technically have only done one method, so don't worry too much about number 1. But the idea that, well, we have a +3/4 and -3/4, I can add these together, get -1/2x equals -9, and solve it pretty quickly. we'll talk about the other method tomorrow. On number 2, is that ready for elimination, or do I need to do something first? Alright, so the first step on all these is not a written step. It's just identifying. If I added both variables together, would one of them eliminate? So if I add 3 and 3, no, it doesn't eliminate. If I add 2y and -1, no, it doesn't eliminate. So I need to do something first. So I need to go through and make one of these negative. Doesn't matter which one I make negative.
No.
No. Yeah, someone else could say, well, I'm going to make the bottom one negative, change this to positive, and make 22 negative. Either way, the x's will eliminate, so it's the end result that you're thinking about. So now if I add them together, okay, yes, I get elimination, and I get -2 minus 1, which is -3, and 22 minus 10, which is 12, and you can finish it up. But the first thing you want to do is like, okay, number 3, hey, that's already a +1, -1, it eliminates, I don't have to do any changing of signs. Okay. Look on the next page. Is there anything there that we're going to worry about? We're hearing?
Mm-hmm.
Okay, and what about 16 is we have a question on? They gave you the equations. Do you know how to solve this?
Yeah.
Alright, so
I'll be sorry if I can use it.
well, try it out on your own first and see how it goes. Yeah, it's just saying there's 2 numbers. If you add the 2 numbers, they equal 65. If you subtract the same 2 numbers, it's 27. What are the 2 numbers? That's a very basic question. You guys could have answered this in 5th grade just by trial and error, just by trying to figure out. You know, is it 40 plus 25? That's 65. Is 40 minus 25 27? No. I just try to figure out what the numbers are. But we're going to do it in a more methodical method. 10. Okay. What do we got on 10? Okay. Well. Yeah. What's the question on 10? Yeah. So same thing here. Don't just say, well, that's a lot of writing. You know, can you do it for me? It's like, well, try it. Oh, I'm just solving what 2 numbers added 65, subtract 27? Okay, I can do that. These are ready to eliminate. I already know that. 2x equals, you know, okay. So give it a shot first. Same thing here. Don't look at 10 and say, oh, there's fractions. I don't know what a half minus a half is. Oh, wait, it's 0. I don't know what -7 ninths is plus 7 ninths. Oh, wait a minute, that's 0 too. Okay, I guess it's not hard. No, you don't want to trick yourself into saying 5th grade math is difficult before trying it. -20/3 plus 6 2/3. 0. Yeah, same thing. Solution? Infinite, yeah. Yeah. Infinite solutions. Yeah, you guys don't give yourself credit sometimes. You're much smarter than you think you are. There's some glasses. Okay. So you have over 10 minutes right now. There's some more word problems over here, but read them. Draw a picture if you need to, but don't just say, well, I have to read, it's too hard. They already give you the equations. That's the hard part. You just have to solve this. And if you look at it closely, oh yeah, 3 times the length equals 144. I guess I can solve that. That's not so hard. Same thing here. So give yourself a break. Realize that these are not so hard, but you do have to get what the length is and then go ahead and find out what W is. Don't just get one answer, because they ask you find the length and the width. So you want to have L and W. Don't forget the units are feet. So you should have two answers. This length is this many feet, the width is this many feet. And if possible, just double check that if you add them all up, it does actually add up to the printer they give you. So you can lots of ways to check. Okay. What about here? What happens if you get this kind of answer? What happens? What's the answer? Infinite. What happens if you get just like x equals 4? How many solutions? Yeah, one solution. What happens if you get like 0 equals 4? No solution. Yeah. We can do all this stuff. We know this. Okay? Don't trick yourself into thinking it's too hard because it's at the end of the homework or it's has basic reading involved. You guys can do this stuff. Okay? All right. Go ahead and use the rest of the period. Work on the hardest problem that there is on there and get that done before you leave today, so you know at least you have the hardest problem done.